So the first one I'm going to talk about is the rasters. So communication through pixels or rasters involve the shading of terrain pixels or cells into colors ranging from 0 to 255. So this works kind of very similar like Photoshop. It also depends on how you symbolize your terrain. So in GIS, this is a GIS image, you can symbolize your terrain. In this particular example, we have symbolized it where the very light colors are 0, and the light colors represent very high elevation, or I'm sorry, the very light colors are the higher number, 255. So the white colors in this image represent very high elevation, and the very darker colors, which are 0, represent lower elevation, we can see here. So this is kind of a drainage area, so you can see the colors get a little bit darker. So these are values that are closer to 0, so it's much lower in elevation. A major limitation can immediately be identified if you are limited to 0 to 255 in values. So some terrains, such as if you're in Colorado and there's a lot of mountains, may have more elevation change. Errors can occur when converting from raster data type to vector. So recall that you have a lot of cells in a raster, and if you had to determine where the contour lines must occur, there can be some error or variation when those contour lines are determined within that cell. So kind of think of it this way. You have a drawing of lines that were done in a very fat, say jumbo-sized crayon, and now you want to convert that to something that's drawn with a very fine pen. So since you have a lot of, for example, in one area, a lot of lines that are really close together, you really can't tell because the crayon drawing, the crayon line is very thick, where a vector line is going to be very, very thin. So how it interpolates or how it figures out where those lines are can vary, so there can be some error there.